Good evening, Titans. And tonight we're going to be discussing how to solve equations by using square roots. We'll look at two main types, and we'll get a feel for both of those tonight. First of all, just recalling what a square root is. And remember, the number that is multiplied by itself to equal another number is called the square root of a number. And every number has two square roots because the square root of a times the square root of a equals a, and the negative square root of a times the negative square root of a is also equal to a. So for example, if we want to get, the square root of 9, well, the square root of 9 is 3, because 3 times 3 is equal to 9. But so is negative 3 times negative 3 is also equal to 9. And since we will be performing the square roots in this chapter, we will be having to use both the positive and the negative square roots. So most of our answers will be plus or minus. So when we have plus or minus the square root of the number, that indicates that we want both roots of a, and it's read plus or minus the square root of that number. First of all, if we're just solving equations in the form ax squared equals k, where we just have the variable squared, well, kind of like when we did radical equations, the first thing we always have to do is we have to isolate the x squared expression. And also, you can never take the square root of a negative number, or at least not until you are taught about imaginary numbers. So if you ever end up with having x squared equals, say, a negative 9, we can't do that, because if we try to take the square root of each side, we get x equals plus or minus the square root of a negative 9, and the square root of a negative 9 doesn't exist in Algebra 1. So we would just say that's no solution. So a couple of examples here. First of all, if we just have x squared equals 25, the x squared is already isolated, so we just square root both sides. And we get x equals, and now we must use the plus or minus, and the square root of 25 is the whole number 5. Here, we'd have to divide both sides by 2 first to isolate the x squared term. So we get x squared equals 5, square root each side, and we get x equals plus or minus the square root of 5. And again, we want to just leave our answer as plus or minus the square root of 5 until we have a need to change it into a decimal format. In letter C, the x squared is already isolated, so we just square root both sides. And we get x equals, again, plus or minus. And remember, the square root of 9/4 is the same as the square root of 9 over the square root of 4, which in this case would be the square root, or plus or minus 3/2. And now this last one, we have to do a little work to get the t squared isolated. So the first thing we have to do is add 144 to each side. We get 25t squared is equal to 144. Divide by 25. And now we have t squared is equal to 144 over 25. And now we'll square root each side. And we'll get t equals plus or minus square root of 144 is 12, and the square root of 25 is 5. And so we end up with t is equal to plus or minus 12/5. So that's the first type of quadratic equation. Now the second type is when we have x squared is the x is an expression like we have here. So we still have to isolate the x squared expression. So we're going to add 49 to both sides here. And now we square root both sides. And when we square root an x squared, we get just what's inside, so x minus 5. And then we take the square root of 49. Well, the square root of 49 is a negative 7 and a positive 7. And so we have two separate equations that we're going to solve. And now we solve for x by adding 5 here. And we get x equals a negative 2. And we add 5 here, and we get x equals 12. So again, we have our two solutions, but instead of just being plus or minus one number, it's a negative 2 and a positive 12, because we had x minus 5 equals a plus or minus 7, we had to add the 5 to isolate the x. So let's look at a couple more examples similar to these. So this first one here, again, we need to isolate the x squared part. So we're going to add 9 to both sides first. And we get x minus 2 quantity squared is equal to 9. And now we're going to square root each side. And again, remember when we square root the squared, we get just x minus 2. And when we square root 9, we get plus or minus 3. And now we solve by adding 2. Now be careful here. I'm kind of doing this in one step. But we have two answers. We have 3 plus 2, which is 5. And then negative 3 plus 2, which would be a negative 1. And those are our two answers. We'll do the same thing on this one. Again, we have to add 5 to both sides first. And we get x plus 4 quantity squared is equal to 5. And now we're going to square root both sides. And we get x plus 4 is equal to plus or minus the square root of 5. And now we'll subtract 4 from each side. And again, in this case, because we want the exact answers, we're just going to leave it x equals negative 4 plus or minus the square root of 5. If there was a need to get decimal approximations, then we would just use our calculator to approximate the square root of 5. Alright, here's an application. It says, find the exact time that it takes for an object to fall from the top of the Leaning Tower of Pisa if the function h equals negative 16t squared plus 185 represents the object's height in feet h after t seconds. Now, hint, what is the height of the object? So, well, if we have the Leaning Tower of Pisa here, okay, and we drop this object off, okay, then let's put windows in this here, alright, and we drop this object off till it hits the ground, okay, well, how long will it take for it to hit the ground? Well, again, the hint is the height of the object. Well, the height of the object when it hits the ground is 0 feet. So we're going to replace h with 0. So we're going to have 0 equals negative 16t squared plus 185. And now we have to isolate the t squared. So we're going to subtract the 185 from each side. So now we have negative 185 equals a negative 16t squared. Divide both sides by a negative 16. And we're going to get t squared equals, if we divide this out, and we have negative 185, and we divide that by a negative 16, we end up with a positive 11.5625. And now we're going to square root each side. And we're going to get t is equal to, now again, this should be a plus or minus. But because we're taking the square root of a number, and this is dealing with time, we're not going to use the plus or minus. And so this would just end up being 3.4 seconds. And again, we just use a positive because, again, it cannot be a negative time. So in this case, if I'm on the top of the Leaning Tower of Pisa and I drop something, then it's going to take 3.4 seconds to hit the ground. So I could have time to yell, "Look out below!" before it smashes them in the head. All right, that's all for this evening, and we'll again address these problems in class tomorrow and have you do some things with them. Good evening.
Made with Doodlecast Pro.